And the function is f of x equal x plus 5 squared minus 4. Now, in the title, I said that we're graphing quadratic functions, but how do you know that this is a quadratic function? Say it again?
It's binomial.
Not because it's a binomial.
The square root sign is in, doesn't have the variable.
The square sign, if you were to FOIL this out, you would get x squared. All right, and so remember, a quadratic function has this form. Y equals ax squared plus bx plus c. So that's the form of a quadratic function. So notice the largest degree term you see is x squared. So if you were to FOIL this out, you would get x squared as your leading term. Okay, now we talked about last class period a couple of forms that this can be written in. Do you remember what form this is called? In vertex form. All right, so in vertex form, it looks like this. F of x equal a times x minus h squared plus k. Now it's called vertex form because from that form you could easily determine the vertex. Do you remember what the vertex is here? HK. And remember, when you determine what the coordinate, what h is, what the value of h is, what the x coordinate of the vertex is, remember it's got to be x minus h. So we did some situations and problems where it was not x minus but x plus. All right, so make sure you know that for your test, that this is the vertex form and the vertex is just HK, hence the vertex form. We also talked about that all these quadratic functions, and you can go back to the video from last class period and from your notes, that we looked at a symmetry. They all have symmetry. What is the name of that line that goes through the vertex? The axis of symmetry. And so your axis of symmetry, once you find your vertex, you know your axis of symmetry. Now, the axis of symmetry is a line, so you have to name it as a line. And what kind of line is it? It's a vertical line. And so how do you name a vertical line? X equal. Very good. So what is your axis of symmetry? Is x equal what here? H. X equal h. All right. So when we, and there will be a problem in your test where one will be in vertex form, and I could easily ask you, if you look at the study guide, I could easily ask you what's the vertex, what's the axis of symmetry. So that's pretty easy to determine if it's in vertex form. Okay, so at this point, let's go ahead. Oh, and the other thing I could ask you is this, now remember the graph is a parabola, right? So is the parabola opening up or down? We had that conversation in last class period. And what determines from here? What determines whether the parabola opens up or down? A. A determines, in both cases, A determines whether the parabola opens up or down. So we spent a brief moment looking at that. If A is positive, the parabola is going to open up, and so your vertex is going to be a low point. So your vertex right here would be a low point, would be a minimum. If A is negative, what does your parabola do? Opens down, and so your vertex would be a maximum. Okay? So in this case, we know that the parabola is going to open up, so that could be a question on your test. It could be a multiple choice question, something like that. I haven't made it out yet, but if you know that I did, then it should be easy points to get. All right, so what is the vertex in this case?
-5.
He said -5. You would lose some points there.
5.
You would lose all points.
Oh, thanks.
He would get some, you would lose all. What's missing? He said the vertex -5. Well, the vertex is a point, right? You got to have an x coordinate and a y coordinate. Negative 5, negative 4. Is that what you said?
No, you let me finish.
Yeah, we didn't get there yet.
Oh. I apologize. You gotta be quick. You gotta be like Speedy Gonzales from the cartoons from a long time ago. Yeah, okay. All right. So negative 5, negative 4, right? Huh? Can you get a what? I can't hear you. An audit of the past test. Oh, I see. No, that window has gone. All right. So the vertex is negative 5, negative 4, right? And I'm glad that none of you said 5, negative 4, because remember, it's got to be x minus h. So a very common mistake people make is they want to say the vertex is 5, negative 4. But remember, it's got to be x minus. So when you think of x plus 5, if you got to do that, then you do what I'm about to do. X plus 5 is the same thing as saying x minus a negative 5. And you've learned that from previous courses. So h in this case is what? Negative 5. Okay? So that's your vertex. Once you find your vertex, you can tell me the axis of symmetry. What's the axis of symmetry? Nope. Nope. X equal. Very good. X equal negative 5. You're just guessing at things, aren't you?
Well, you don't like one answer, so I gotta get the other option.
Process elimination.
But he still had a few things to eliminate, didn't he? He still had a few things to eliminate before he got to that part. So it's x equal because the axis of symmetry is a vertical line, isn't it? And so you've learned many years ago that you name a vertical line as x equal. You name a horizontal line as what? Y equal. Okay. Y equal a number. Okay, so we found the vertex, we found the axis of symmetry, and so the idea is this. I think we can go to the small graph for that one. So at this point, I'm going to do this. I'm going to go ahead and plot the vertex. So the vertex is negative 5, negative 4, right? So go ahead and do that. So there's your vertex right here. And I know that the axis of symmetry is x equal negative 5, and you use the axis of symmetry to help you with the symmetry part, to make it look symmetrical. And so what we're going to do is you're going to use a dotted line to represent the axis of symmetry because it's not really part of the graph. It's just an attribute of the graph to help you with the idea of symmetry. So you use a dotted line, just like this, that goes through the vertex. All right, so that's how you're going to do the axis of symmetry. Now remember, you got to graph a parabola, and so you need some more points, don't you? All right, so here's what I'm going to ask you to do. So one of the things you're going to be told to do in this case is to find the X-Intercepts. So let's find the X-Intercepts. All right, now everything you know to do this, you've had already. You had on the last test, you had in the previous course, you had in the previous course before that, and so on. So that part's not new. For example, what's going to happen? To find the X-intercept, what do? You let y equal 0, right? So you let y equal 0. That's not new. You know how to do that. What in this situation, though, represents y? No. F of x. F of x represents y. So I'm going to set this thing equal to what? 0. So I'm going to say x plus 5 squared minus 4 equals 0. And you had this right here on one of the tests. It wasn't on test 3. It was on test 2 possibly, and you had it in a previous course. What is the best way to solve this quadratic equation? Subtract 4, and you're going to use what property? Square root property. No, I wouldn't use FOIL. I'd use a square root property. So I get x plus 5 squared equals 4. and then take the square root of both sides. Remember, you do that, though, you get a what? Plus or minus. And so the square and the square root into each other, so you get x plus 5 equal plus or minus 2. And remember, I ended up with the square root of 4 being 2. So I'm going to end up with rational solutions. So that's where you went ahead and you split them apart. Remember last class period we approximated at some point? Not here, because the square root of 2 is exactly equal to what? I'm sorry, the square root of 4 is exactly equal to 2. So we get this. We get x plus 5 equal 2. X plus 5 equals negative 2. And then how do you get x by itself? Subtract 5 from both sides. And so one of my x-intercepts is what? Negative 3. And the other x-intercept is what? No, what's a negative 2 and a negative 5? Negative 7. Y'all starting to concern me sometimes. All right. So now we have a few more points to plot, don't we? And I want you to know something when we plot this. Remember, use the axis of symmetry to help you. So I'm plotting the point negative 3, negative 7. So look how easy this is. So here's negative 3. Here's negative 7, right? Look at those x-intercepts. They better be the same distance from the axis of symmetry. Are they? Yes. So if you had made a mistake with this and it didn't look the same distance, you know you did something wrong. You go back and you figure out what you did wrong. Is that clear? All right. So these distances better be the same. That's the idea. That's symmetry. Okay? Now, I'm going to ask you to find the y-intercept because all functions have a y-intercept. So you're always going to have a y-intercept. Let me rephrase that. All polynomial functions have a y-intercept. Okay, all polynomial functions have a y-intercept. So let's find it. So now we're going to find the y-intercept. To find the y-intercept, what do? Let x equal 0. All right, now I'm going to go ahead and rewrite this as y equals. So y equals x plus 5 squared minus 4. All right? So I just rewrote f of x as y. So to find the y-intercept, you let x equal 0, correct? All right, so here we go. Y equals 0 plus 5 squared minus 4. Agree? And what's 0 plus 5? 5 squared is 25. So I get y equals 25 minus 4, which is 21. So the y-intercept is 21. All right, well, that's way out of my range, right? So that's way up here. Y'all agree? All right. But I could actually find the y-intercept. I'm not going to use it because it's out of the range. See that? But we still need, remember, to graph a parabola, I need for you to plot 5 points. So far we have how many? 3. I need 2 more. All right, now here's what I would do. I would see letting x equal 0 is going to be outside here. So I'm going to let x be negative 1 and negative 2. Okay? I'm going to let x be negative 1, negative 2. All right, so watch. Use a t-table. Negative 1. If x is negative 1, I get y equals negative 1 plus 5 squared minus 4. Y'all agree? Negative 1 plus 5 is 4. 4 squared is 16. 16 minus 4 is 12. Okay? Let's try negative 2. Negative 2. If x is negative 2, I get y equals negative 2 plus 5 squared minus 4. Because remember, wherever x is, what do you substitute? Negative 2. What's negative 2 plus 5? 3. And 3 squared is 9. And 9 minus 4 is 5. So I'm going to use that one. So what I did was this. The y-intercept, I found the y-intercept, but it was outside my coordinate plane. So I don't want to use it. Okay, so I want to use points that are inside here. So then what I did, since x, now listen to my thought process. Since x, remember I let x be 0, right? So that's this. So 0, what was it, 20, 21? 21's way up here. So I need to pick another x value. Would you pick an x value on this side? No, because it'll be even further up there, right? So pick something between this x-intercept and x equals 0. So I chose -1 and I chose what? -2. To make things work within this coordinate plane, which of these 2 points do you think I would choose?
The second one.
The second one, -2, 5. All right, so -2, 5 is right here. Let's see it. Now, all you do is use symmetry. Listen to this. How many units is this point that I just plotted away from the axis of symmetry?
3.
So I go 3 units to the other side. 1, 2, 3, and there's the other point. See what I did? Use symmetry. So I found this point. So then I go the same distance to the other side and I get that point. Now watch, it does work. What's that x coordinate right here?
-8.
-8. Okay, listen carefully. All right, I'm going to show you it does work. You don't have to do all this work to get it. If x is -8, I get y equals -8 plus 5 squared minus 4. What's -8 plus 5? -3. And what's -3 squared? 9. And what's 9 minus 4? 5, which is what this was. Okay? And you're done. All you do is just draw your parabola. Just make it look like a parabola. Do the best you can, like that. Okay? Just make it look symmetrical. All right. Now, also in your test, once you graph it, you can then tell me where the parabola is increasing, decreasing, and so forth. All right. So that same situation, f of x is decreasing, and then f of x is increasing. All right. So remember, to determine the intervals where the function is increasing or decreasing, that was on your second test and your third test, you got to use the x-axis. You got to use your domain. So from -infinity to -5, you see that? What are those y values doing? Decreasing. And from -5 to infinity, what are your y values doing? Increasing. All right, so remember, for increasing, decreasing, use opening intervals. So where's it decreasing? -infinity to -5, and where's it increasing? Yeah. Now, what is the domain of f of x? And you don't even have to look at this. I'm covering it up. Why? Why is it all real numbers? Because it's a polynomial function. Good. You remember something from test 3. It's a polynomial function. You didn't have to use this graph. Although now you see it, it's all real numbers, right? If you go along the x-axis, it's all real numbers. So -infinity to infinity. What's the range? The range of f of x. So remember, the range you go along the y-axis, not -5, that is -4 to what? Infinity. But remember, that's where you're going to need those brackets. So -4 with a bracket to infinity with parentheses. Okay? All right, so that was the first one. All right, let's look at another one. All right, so let's get number 2. Suppose at number 2, we had this. All right, number 2, let's suppose it was y equals -3 times x minus 4 squared plus 12. -3 times x minus 4 squared plus 12. Okay. Is this a quadratic function?
Yes.
Yes, because if you were to multiply this out, for all this out, you would get -3x squared, right? That's what you would get. What form is it in, though? Vertex form. So if it's in vertex form, so this is vertex form. So it's in vertex form. You can easily determine the vertex. What's the vertex? No. 412. 412. Remember, it's got to be x minus h. And what is h in this case? And it's already an x minus, right? So h is 4. So I'm noticing this. At the first problem, this person got it correct. The second problem, person got it wrong. It's the same idea. All right, once you find the vertex, you now know your axis of symmetry. X equal what?
4.
Very good. All right, x equal 4. Now I'm going to go ahead and use the larger grid paper for that one, the larger one. All right, so x equal 4, right? Okay, so at this point, I'm going to go ahead and plot the vertex. Oh, by the way, is the parabola open up or down?
Down.
Opens down because a is negative. In fact, what is a in this case? Negative 3. So the parabola opens down. Since a is less than 0. Remember, a here is negative 3. Okay, so the vertex is 412. So 412 is right here, right? All right, and we know it opens down. So since it's opening down, am I going to have any x-intercepts? Yes, you will. It opens down. It's going to cross the x-axis, right? If the parabola opened up, would you have any x-intercepts? No. In fact, if I said, what are the x-intercepts, you would say none, right? There are no x-intercepts. All right, so you understand that, right? All right, so your vertex is above the x-axis. Your parabola is opening down. So there will be what? There will be what? X-intercepts. Let's suppose this. Suppose your vertex is above the x-axis and your parabola opens up. Will there be any x-intercepts?
No.
Will you take the time to find them?
No.
No, there aren't any. Okay? All right. So then don't forget to draw your axis of symmetry. Axis of symmetry. Dotted line. Do the best you can with drawing a dotted line. All right. Let's go ahead and find the x-intercepts. To find the x-intercepts, you let y equals 0. Now, originally it would have been, I'm going to go ahead and change this to, let's say, g of x. So it would have been g of x equal. So you let y equals 0. What in this situation represents y? G of x. So I'm going to take this function here, this expression that's on the other side. I'm going to set that equal to 0. So I get negative 3 times x minus 4 squared plus 12 equals 0. When it's in vertex form, how are you going to solve this quadratic equation if it's already in vertex form?
You're gonna move your 12 over.
It's using a square root property, right? Okay, square root property. So you're going to bring the 12 to the other side. So I'm going to get negative 3 times x minus 4 squared equals a negative 12. What else do you need to do? You got to divide by negative 3 first. Remember, in order to use the square root property, this number in front of that parentheses has to be a 1. So divide by negative 3. And then these divide out. So I get x minus 4 squared equals a positive 4. And now what's the next step? Take the square root of both sides, plus or minus. So I get x minus 4 equals plus or minus 2. So since I ended up with rational solutions, notice the square root's not there anymore. So if it was still there, it would be irrational. You would approximate to graph. But since there's no longer a square root, you can exactly tell me what the x-intercepts are in terms of a whole number or an integer. So positive 2, x minus 4 equals to a negative 2. So over here, to get the x-intercept, you're going to add 4 to both sides. So there's going to be one of them is 6, and the other one is 2. All right. Now, when you plot them, you need to make sure that they're the same distance away from the axis of symmetry. If they're not, then there's some issue here. So positive 6 and positive 2. So here's 6, here's 2. Are they the same distance from the axis of symmetry? Yes. Now I'm going to ask you this, and I want you to think about this. Now remember, all polynomials have a y-intercept. Will the y-intercept be above the x-axis or somewhere below? Yeah, below, because it's got to do this, right? So it's going to cross somewhere below. So let's see where it is. Let's go ahead and find the y-intercept. Now to find the y-intercept, you're going to let x equals 0. So I'm going to go ahead and rewrite the function over. So y equals negative 3 times x minus 4 squared plus 12, right? And so where we see the variable x, I'm going to plug in 0. So I get the y-intercept is going to equal negative 3 times 0 minus 4 squared plus 12. What's 0 minus 4 squared?
4, negative 4.
So 16, right? What's 16 times a negative 3?
Negative 48.
Yeah, so that's going to be way out there. So what's the y-intercept? Where will the graph cross the y-axis?
Negative 36.
Yeah, which I don't have enough, right? All right, but there's the y-intercept. So we can do what we did the previous time. So remember, I let x be 0, and I got way down here, right? Okay? So I've got to pick a number that's between 0 and what? 2. So give me a number between 0 and 2, a whole number. An integer. 1. You only had one choice. 1.
1.5.
Yeah, you could use 1.5. I don't want to do it in any fractions or decimals, so that's why I always use integers. So you could use any number between 0 and 2 like he did, but always try using an integer. It makes things a lot easier for you. So hopefully 1, if I let x be 1, it'll be somewhere around here. Let's see. So if x is 1, I get negative 3 times 1 minus 4 squared plus 12, right? What's negative 1 minus, 1 minus 4? Negative 3. What's negative 3 squared? And 9 times a negative 3? Negative 27. Negative 27 plus 12 is negative 15? Is that right?
Yes.
All right, which I have enough of. So 1 negative 15 is way right here, right? Okay, remember, I need you to plot at least 5 points. So once you know that one, you know what the other one is. So notice that point I just plotted is how many units from the axis of symmetry? 3. So I go 3 units the other way. 1, 2, 3. So there's where that other point would be. And then just do the best you can. Do the best you can. It's going to be real skinny. Do the best you can with drawing this. Okay? Just make it look like a symmetrical parabola. Just make sure that parabola looks symmetrical. Do the best you can. So, let's see. All right, so you get something that looks okay. All right, you see it? All right. All right. So the one of your tests, there will be x-intercepts, and I'll try and make the y-intercept where it actually crosses, where it could actually cross. Okay. Any questions at this point? Okay. So if it's in vertex form, you know how to do this. Okay. Now it's important you know how to find the x-intercept. So if it's in vertex form, you're going to find the x-intercept using the square root property. Correct? All right. Now let's talk about this. What if I had this? Oh, and you know, I could also ask you this, and I didn't do it, but let's kind of talk about this real quick. Where, I remember I call this g of x. So the question is, where is g of x increasing? And then where is g of x decreasing? All right, so from negative infinity to 4, what are your y values doing? Increasing. So they're increasing from negative infinity to 4. And then from 4 to infinity, what are those y values doing? Decreasing. So from 4 to infinity. All right. And without looking at the graph, you can tell me what the domain of g of x is. What's the domain? So it's all real numbers. Why? Without looking at this, you could tell me that. Why? It's a polynomial function. Remember, all polynomial functions, that was in your test last class, your last test. So all polynomial functions, the domain's all real numbers. And then the range of g of x, what's the range? Remember, it's going down, so what's the range? Negative infinity to, what's that y value? 12. So negative infinity to 12 with a bracket. Okay? All right, so that was number 2. All right, now let's look at number 3 now. Okay, number 3. All right, number 3, suppose we had this for number 3. Suppose we had this. We had k of x equal negative 3x squared plus 12x minus 4. So k of x equals negative 3x squared plus 12x minus 4. Now, what form is this? Well, first of all, is it quadratic?
Yes.
Yeah, that one is easy to see for most of it because it's ax squared plus bx plus c. Is it in vertex form? No, it's not in vertex form, so you can't easily, within 1 second, tell me where the vertex is. What form is this? Huh? General or standard, whatever, depending on the textbook. So it's either general form or standard form. But you got to find the vertex still, right? Because remember, all quadratic functions have a vertex. Now, there's a formula for this. I'll give you the formula. You just got to know how to use it. So you don't have to memorize it. So the vertex, remember, the vertex is still hk, right? But to find h, it's, and remember, if you remember your quadratic formula, remember the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. You could tell me what the vertex is, which part of this will give you the x coordinate of your vertex, which one? Negative b over 2a. So h is negative b over 2a. That's the x coordinate of your vertex. Now again, I'll give you that. You just got to know how to use it. And then how do you find k? Once you find h, how do you find k? Once you find your x coordinate, how do you find your y coordinate? You plug h, you plug it into your function. You had this in your last test, didn't you? On your last test, guys, you got to make some connections now. On the last test, you had something like this. If f of x is let's say 3x squared minus 7x plus 2, and I told you to find f of 3. So once you find the x coordinate, how do you find once you find x, how do you find the y? You plug it in. Same idea. But we got to find the x coordinate first. All right, so what is a? Negative 3. What is b? 12. And what is C? Negative 4. All right, so let's find the x coordinate of the vertex. So h will equal the opposite of b. If b is 12, what's the opposite of 12? Negative 12 over 2 times a. What's a? Negative 3. So that's negative 12 divided by a, negative 6. And so what's the x coordinate of my vertex? 2. So this becomes 2 comma something, right? In fact, even before you find what the y coordinate is, you can tell me the axis of symmetry now. What's the axis of symmetry? X equal 2. That's your axis of symmetry. So you don't have to find the y coordinate at all. You just need to know x coordinate to determine the axis of symmetry. All right, now once you find h, how do you find the y value? How do you find k?
Plug in 2.
Yeah. Now, don't confuse, I should have been a little bit more careful. Don't confuse this k with this k. Is that clear? So maybe I should have just called it f of x. so that k of x was not the same thing as this k. All right. So how do you find the y coordinate of the vertex? You got to find f of what? F of 2. So that's going to be equal to k. So k will be f of 2. So how to find f of 2? Where we see the variable x, what do you plug in? 2. So get negative 3 times 2 squared plus 12 times 2 minus 4. Okay, order of operations. You got to square first. What's 2 squared? 4 times negative 12. Negative 3. 2 times 12 minus 4. What's this? And what's 12 minus 4? 8. So I found the y coordinate of my vertex. What's the y coordinate of my vertex? 8. Okay. So I'm going to go ahead and use. I think we're okay with using a small grid. So use a small grid for that one. So far, I know my vertex. My vertex is 2, 8. So that's here, right? And I know that the parabola opens down, correct?
Yeah.
So I am going to have X-intercepts. Is that clear? All right. You're always going to have a what? Which intercept? A Y-intercept, because all polynomial functions have a Y-intercept. And here's your axis of symmetry. Okay, now, let's find the X-intercepts. X-intercepts. I'm going to go ahead and use another sheet of paper. All right, listen carefully to this. This is going to be a little bit of work. To find the X-intercepts, what do you do?
Let y be 0.
Let y equal 0. What part of my function represented y? F of x. So I'm going to set this thing equal to 0, right? Okay. So I'll get negative 3x squared plus 12x minus 4 equals 0. Last semester and beginning of this semester, how did you solve this quadratic equation? Quadratic formula. That's what you did. What is A again? What is B? And what is C? Negative 4. And so remember, the quadratic formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So let's go ahead and plug in. What's the opposite of B? What's the opposite of 12? Negative 12. Plus or minus the square root of B is 12, so I'm going to square it, right? Minus 4 times A. A is negative 3 times C, which is negative 4, all divided by 2 times negative 3. That part's not new. You had this on the second test or the first test. That part's not new. You had this last semester as well. That was on your final using a quadratic formula. Now let's deal with the discriminant. Remember the n b squared minus 4ac, that's called the discriminant. What is 12 squared? Okay, so far I have this, the negative 12 plus or minus the square root of 144. First of all, what's a negative times a negative times a negative?
Negative.
A negative. So I'm going to be subtracting something. What's 4 times 3?
12.
And what's 12 times 4?
I got 48.
So 48, right? So 144 minus 48. Use your calculator to help me with this. What's 144 minus 48? What is it? 96? Okay. So negative 12 plus minus the square root of 96 divided by negative 6. All right, so listen carefully now. So we're graphing. The idea here is to graph. So there's no way you can look at this and tell me where in the plane these x-intercepts are located. The way it's written. So you have to approximate. Now, is 96 a perfect square? No. So you can use your calculator to help you with this. But how many x-intercepts are there? 2. One of them is negative 12 plus the square root of 96 divided by negative 6. And what's the other? Minus the square root of 96 divided by negative 6. All right, now make sure you can use your calculator with this. Here's what you're going to do. All right, negative 12 first. So notice negative 12 plus, you guys do the square root button. So the square root button is right above the x squared. So, but you got to use the second function. So second x squared, see square root button? What do I type in next? 96. Now that's the numerator. So press enter. Press equal. So that's my numerator. But I got to divide that by what? Negative 6, and then press equal. Let's approximate the nearest tenth. What's one of my x-intercepts? 0.4? 0.4. Okay? Let's do the other one. Let's do the other one. So negative 12 minus, you guys say second square. So you get that square root function now. What do I type in? 96. What do I do next? Equal. That's your numerator. Then what do I do next? Divide by negative 6 equal. And I pressed equal too many times. See? So let me do it again. Negative 12 minus square root of 96. You got to be careful. Press it only once. Equal. Okay. Then divide by negative 6 equal 3.6. Is that what you got?
Yep.
Okay. 3.6. All right. Now, when you plot those points, you're approximating, but they better be the same distance from what idea?
Your
Axis of symmetry. Okay. So let's go ahead and plot those. So 3.6 is, I'm going to go ahead and expand it up here. Let's see, zoom. All right, so I'm trying to expand it up here. And then I'm trying to do it here. Let's see. Okay, so let's see what we get. All right, so 3.6. Y'all agree? If this is 3, this is 4, 3.6 is about right here. Just do the best you can with approximating it. And where's the other x-intercept? 0.4, so it's about halfway between 0 and 1, almost. And it kind of looks like they're the same distance, doesn't it?
Mm-hmm.
All right. Now, you're always going to have a y-intercept. Let's see if my y-intercept's going to be a nice one. And when I say nice, I mean it's actually going to show up this time. Okay, so notice, guys, whenever, we talked about this last time, whenever your function is in this form, where it's in general form, you know which term represents the y-intercept. Which of these represents the y-intercept? Do you remember? C. C is the y-intercept. Because remember, to find the y-intercept, what do you let be 0? X. Well, if x is 0, then this term is 0, this term is 0. What's left? Your constant, C. So right away, you can tell me what the y-intercept is here. What's the y-intercept? -4. That's your y-intercept. All right. If you didn't know it, then go ahead and do the work. To find the y-intercept, you let x equals 0. And so when I let x equals 0, I get -3 times 0 squared. So y-intercept will be -3 times 0 squared plus 12 times 0 minus 4. Well, that's 0. That's 0. And what's 0 plus 0 minus 4? -4. So there's your y-intercept. So then I'm going to plot that point. 0, -4. So that's about, so 0, -4. It's about here. Now remember, I want you to plot at least 5 points. So far I have 4 of them. 1, 2, 3, 4. What you found this point, use the idea of symmetry to find the other one. How many units is this from the axis of symmetry? 2. So I got to go 2 units this way. And then do the best you can with making this look like a parabola. Oops. You have a pencil, so you can't erase if it doesn't look good. Do the best you can. Mine's not looking good, but
That looks great to me.
thank you. Of course, you do know it doesn't do this, right? It looks like it's doing this. Y'all do know that, right?
Looks like a Christmas tree.
Yeah, it does, doesn't it? Like a Dr. Seuss Christmas tree.
Too early, we still got Thanksgiving.
We're working with positive enforcement here.
All right, so that's it. Any questions on that? Okay. All right, let's do one more with this. All right, let's suppose we had this one. So this one be in journal form as well. So this is number 4. So let's suppose we had this. We had f of x equal 2x squared plus 8x plus 6. 2x squared plus 8x plus 6. All right, we got to find the vertex. So let's find the vertex. So the vertex, remember, is HK. Is this in vertex form? No. So you got to use the formula for that then. So H is -b over 2a. What is a in this case?
2.
What's b? And what's c? 6. So this becomes the opposite of 8. So that's -8 divided by 2 times a. A is 2. So that's -8 divided by 4, which is -2. So far, I've found the x-coordinate of my vertex. Now I've got to find the y-coordinate. How do you find the y-coordinate? You go to your function f, and where we see the variable, you plug in the variable x, you plug in -2. So k will be f of what? -2. So I'm going to get 2 times -2 squared plus 8 times -2 plus 6. Remember, you got to square first before you multiply by 2. So negative 2 squared is 4. 4 times 2 is 8. 8 times the negative 2 is negative 16, and then plus 6. So 8 minus 16 is a negative 8. Negative 8 plus 6 is negative 2. Is that right? So my vertex is negative 2, negative 2. Just using a formula. Okay, once you find once you found H, you know your axis of symmetry. What's the axis of symmetry? X equals negative 2. Is this negative 2 though, right? Okay. Now, does the parabola open up or down? It opens up because A is positive. All right, so it opens up since A, which is 2, is greater than 0. So A is positive. So since A is positive. All right, so I think we can use the small grid for that one. So if you need some more grid paper, just go and get some more. So negative 2 is in the third quadrant. And you go ahead and draw your axis of symmetry using a dotted vertical line. You're going to use that to help you with symmetry. You know right away, let me ask you this. So there are X-intercepts, yes or no?
X-intercept, yes.
Why do you know that there are going to be X-intercepts? Because it goes up, and since the vertex is below the x-axis, when it goes up, it has to cross the x-axis, doesn't it? Now, which one's the easiest to find here? Is it the X-intercepts or the Y-intercept? The Y-intercept. The Y-intercept's the easiest to find. In fact, you can tell me what it is right away. What is that Y-intercept? 6. Because remember, to find the Y-intercept, if it's in standard form or general form, it's always your constant. So if you want to find the Y-intercept, you let x be 0, right? And so then y equals 2 times 0 squared plus a times 0 plus 6. So I get 0 plus 0 plus 6, which is just 6. So that's your Y-intercept. So it's going to cross the Y-axis here. Once I've found that one, then I know another point. What other point do I know on that line? I mean, on that graph, on that parabola? Huh?
2 to the left.
2, yeah, so since this point is 2 units from the axis of symmetry, I'm going to go 2 units this way. So it would be the point negative 4, 6. Okay? But I need to find 2 more points, so that's going to be your X-intercepts, which we're going to approximate. All right, so let's find the X-intercepts. All right, to find the X-intercept, you let y equal, I'm sorry, what do you let be 0?
Y.
Y. So y be 0, which is f of x. So you're going to set this whole thing equal to 0. So 2x squared plus 8x plus 6 equal 0. And then we're going to use the quadratic formula. Again, a is 2, b is 8, c is 6. So your quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, right?
Yep.
Okay, what's the opposite of b in this case?
Negative 8.
Negative 8. Plus or minus the square root of b. What's b?
8.
I square that. Minus 4 times a. What's a? Times c, which is 6. All divided by 2 times a. And what's a? 2. So I get negative 8 plus or minus the square root of 8 squared is 64. All right. A negative times a positive is a negative. 4 times 2 is 8. 8 times 6 is 48 all over 4, right? So that's negative 8 plus or minus the square root of, that's 64 minus 48 is what? No, it can be, huh? 16? Over what? 4. Square root of 16 is 4. All right, so listen carefully. Listen carefully to this. Am I going to be approximating?
No.
No, because you can easily tell me what those x-intercepts are. They're going to be rational numbers. So break it apart. You get negative 8 plus 4 over 4. And what's the other one? What's the numerator over here? Negative 4 though, right? And what's negative 4 over 4? Negative 1. So there's one of your x-intercepts, negative 1. The other x-intercept, what's negative 8 and negative 4? Over 4, which is negative 3. So there's the other x-intercept. So remember when you solve those quadratic equations, and you got those solutions happen to be what part of the graph? The x-intercepts. That's what they are. So then we're going to plot those, negative 3 and negative 1. So here's negative 3. Here's negative 1. Are they the same distance from the axis of symmetry?
Yes.
Yeah. All right, we just draw the graph and we're done. Just do the best with drawing this. Make it look symmetrical. Make it look symmetrical. Make it look like a parabola, though. So something like that. Okay? Now I need to do another one where we actually have to use the calculator to approximate. So let me go ahead and do one more. This one, you'll do realize that since the square root of 16, since 16 was a perfect square, that these are rational, right? The one we just did a while ago. Make sure you understand this. The one we did a while ago, and we talked about this in a previous lesson. If I can find it real quick. That wasn't it. Okay, the one we did a while ago, right here. When I found these x-intercepts, when I solved this quadratic equation, the square root of 96, 96 is not a perfect square. So I'm going to end up with irrational solutions. So that's where we had to do what? Approximate. Okay? All right. All right, let's do one more. Hopefully this one we're going to actually use the calculator because you need to remember how to use a calculator. Okay, so let's suppose we had this one. So this will be number 5, I think. And it'll be the last one we'll do. Number 5, suppose that f of x is negative x squared plus 3, let's make it 6x, plus 6x plus 7. Okay? All right. So, let's find the vertex. The vertex, remember it's hk. What's the formula for finding h of the vertex?
Negative 3 divided by 2a.
All right, let's go ahead and determine what a is. What's a?
Negative 1.
Negative 1, good. What's b? And what's c? 7. So, what is the opposite of b? Negative 6. So, if b is 6, the opposite of that's negative 6. Over 2 times a, what's a?
Negative 1.
Negative 1. So, that's negative 6 divided by negative 2, which is 3. So, I found the x-coordinate of the vertex. And right away, I know the axis of symmetry. What's the axis of symmetry? X equals 3. So I have that vertical line going through the vertex. How do you find the y-coordinate? So how do you find k? How do you find the y-coordinate?
Plus 3 and
So you're finding f of what?
3.
Not 6. 3. You said 3 or 6?
3.
Oh, okay, I'm sorry. All right, f of 3. Now be careful how you do that. Remember, what's the only thing being squared here?
The X.
the x. So you're going to have to write this. Look, negative in parentheses 3 squared, just like that, right? So do y'all agree that negative x squared like this means that when you evaluate this term, it's going to be a negative 9, not positive 9? Okay, negative 9. Plus 6 times 3 plus 7. So that's negative 9 plus 18 plus 7. So that's 9 plus 7, which is 15? 16? So there's your vertex. Y'all agree? So I'm going to use a grid. I'm going to use a big grid paper, so I'll have enough room. So 316 is here, right here. So 316 is right here. Here's the axis of symmetry. Okay. Now, is a parabola open up or down? It opens down. Why does it open down? Now, that's a negative right here. Why does it open down? Because A is negative 1. Opens down since A equals negative 1. So, am I going to have any x-intercepts?
Yes.
Yes. I'm always going to have which intercept? Y. You know what it is right away. What's the y-intercept? 7. So if you didn't see that, remember your y, whenever it's in general form or standard form, your y-intercept is always your constant, c. Now, don't confuse that with this, what we did earlier at the beginning. Don't confuse it with this. You might think, well, there's my constant, so that's my y-intercept. No, that is not c. See, that c is your y-intercept. That's not the same as this c, right? So to find the y-intercept in vertex form, what is it you got to do? You actually have to do what? To find the y-intercept, you actually have to do what here?
Equal to 0.
No, that's to find the x-intercept. To find the y-intercept, what do? You got to let x be 0. You got to do that work. Remember, we did it here. So your y-intercept turned out to be 21. The whole point that I'm mentioning here is that don't confuse this c with this number right here. That is not vertex form. This is vertex form. In vertex form, you actually have to do the work, right? Okay. All right, we did that. We had that discussion at the beginning of class. All right, now, so is this the one we're at? Yeah. Okay, so we have x-intercepts. We also know the y-intercept. What's the y-intercept? 7. Y-intercept is 7, right? If you weren't sure, you let x be 0, correct? Well, if x is 0, this becomes negative 0 squared plus 6 times 0 plus 7. So that's 0 plus 7, which is 7. Okay, let's talk about the x-intercept now. How do you find the x-intercept? I know I have them because the graph goes through the x-axis. You let y equals 0. So I'm going to go ahead and rewrite the function over. This was my function. Okay, now, so A is negative 1, B is 6, C is 7. So to find the x-intercept, you let y equals 0. So basically, you're going to take this function, this expression on this side, say equal to 0. So I have this quadratic equation, so I'm going to use a quadratic formula. Chances are it's not going to be factorable, so use the quadratic formula. So x equals, the x-intercepts will equal. What is the opposite of b? Remember, here's a formula. All right, so negative 6 plus or minus the square root of b. What's b? 6. I'm squaring that. minus 4 times A, what's A? Negative 1. Times C, 7. All divided by 2 times A, and A is negative 1. Okay, let's deal with the discriminant. 6 squared is 36. What's the negative times a negative times a positive? A negative times a negative times a positive. Positive. What's 4 times 1 times 7? 28. All over negative 2, right? Okay, what's 36 plus 28? Oh, 64? Oh, doggone it. I meant for it to not. Okay, all right. Shoot. Okay. So the square root of 64 is what, though? 64 is a perfect square. All right. Oops. So that's negative 6 plus or minus 8 over negative 2, right? Okay. So negative 6 plus 8 over negative 2, and the other will be negative 6 minus 8 over negative 2. What's negative 6 plus 8? And what's 2 divided by negative 2? Negative 1. So there's your first x-intercept. The other one, what's negative 6 and a negative 8? And what's negative 14 divided by negative 2? 7. All right. So then we get the y-intercept was 7 to begin with, right? And so my x-intercept's a negative 1, which is here. And my y-intercept, the other x-intercept is 7, which is here. Always verify that those distances are the same, or those distances are the same. All right. Now we plotted the y-intercept. When you plot the y-intercept, you can now tell me the other point that has symmetry with it. How many units from here? How many units? 3, right? 3. So I go 3 units this way. 1, 2, 3. So there's the other point. Okay, so then you just draw your parabola. Do the best you can. Do the best you can. And there you go. Okay? All right. Now, let's suppose you found the x-intercepts, okay? Let's suppose you found the x-intercepts. And you plugged A, B, and C back into quadratic formula, but let's suppose this was what you ended up with. I'm making this up. Negative 3 plus or minus the square root of 28 divided by, let's say, 2. I made it up. Is 28 a perfect square? No. So now you get to approximate. So I was trying to get another one like this. So you got to have irrational solutions, so irrational roots. So we have to approximate this. Negative 3 plus the square root of 28 over 2. Negative 3 minus square root of 28 over 2. So on your calculator, how would you approximate this? What do you type in first? Negative 3. So you're going to say negative 3. What else? Plus, and you're going to say square root, like that. What do you type in next? What do I do? Equal. So that's your numerator. Then what? Divide by 2. You get 1.1. Okay. The other x-intercept, you're going to say what? Okay, negative 3 minus square root 28 equal. Divide by 2 equal. And the other one is negative 4.1. All right. So y'all know how to use your calculator, right? Okay. So on your, so that now we're going to talk a little bit more about this next class period, but you have enough now to get you ready for that part of the test.